Okay, so today we will talk about finding components, more examples. On the previous video that we did, we had to see and be able to visualize how the vector will look like when we are saying it in English, or when we have a vector or graphical representation of the vector, then we figure out what is the direction. So I will do a short review of this. Vectors can be represented in different ways. So the first one is bearing, and this is the one that is used most or initially. The second one is the one that is dealing with positive x-axis. And the third one, which we will use the most, is in reference to north, east, south, west axis. So when we are talking about bearing, we have to, along with the magnitude that is numerical value of the vector, and it's represented by the line segment of the graphical representation of the vector. We have to identify the angle with the north axis clockwise. So north axis is, we always think that is going up. And if we have a vector that is, let's suppose a vector A with magnitude 20 kilometers per hour, with a bearing of 110 degrees, then the way that we express it into English is 20 vector A, 20 kilometers at 110 degrees bearing. And when we are dealing with the positive x-axis, we know that x-axis, or we know how the Cartesian axis look like, x and y axis. They intersect at a point that is 0, 0, and whatever is on the right is considered to be the positive one, whatever is on the left is negative, and for the y, whatever is up is positive and whatever is down is negative. For when we are describing a vector using the positive x-axis, so we will consider just this positive x-axis. So we have the positive x-axis. And then if we have a vector, let's say we have a vector b that is 15 kilometers at 120 degrees with positive x-axis, then the angle 120 is considered as a counterclockwise. However, the most used will be the one that is dealing with northeast southwest axis. So when we see northeast southwest axis, we see something like this, which is pretty similar to the x and y axis. So this will be y and this will be x. It's pretty similar to the Cartesian axis that we are using in math. So on the examples that we had on the previous classes, so we talked about the vector that is in one of those quadrants, northeast, northwest, southwest, or southeast. Let's start with a specific case. Let's suppose that we have a vector A that is 18 meters per second due north. So when you see this, that means that this vector is like this. So this is vector A, and the magnitude of it is 18 meters per second. So it's going straight north. Or when we have a vector, let's say a vector B, that is 13 kilometers due south, then what you will see as a vector, or the graphical representation of that vector, will be this one here, where the length of the line segment is representing 13 kilometers. And so it goes if we have a vector that is due east. So if we have a vector C that is 18 kilometers due east, then the graphical representation of this vector will be something like this, where the line segment of this vector is representing 18 kilometers. And if we have a vector D that is 25 kilometers per hour due west, then the graphical representation of this vector will be something like this. And the line segment that represents this vector will be 25 kilometers per hour, will be representing 25 kilometers per hour. So now, this is when we have due in one of the axes. But the second case, which we kind of saw it even on the class yesterday, is when we have a certain angle. So let's suppose that we have a vector A, that the English part of it is 20 newtons at 30 degrees north of east. So what do we have in this case is it's between north and east. This part here is expressing the magnitude, is giving us the information about the magnitude of the vector along with units. The fact that we have newtons is telling us that we are dealing with a force. The second part, or whatever is after that, is telling us what is the direction of this vector. As we mentioned even yesterday, there are two parts on this. Is this north of east, and is this angles. So the first letter of the north of east part, or axis, is telling us where is the vector going. So you know now that the vector is going north. But to go north, you have two ways. You can go east, from east, and you can go from west. And the second letter, it's telling us starting from which point. So now we have a vector that is going north, and it's starting from east. And the value here tells us up to what angle. So what is the angle that is going? Starting from east, going up to the angle. So the graphical representation of this particular vector will be something like this. This is a vector A. We are starting from east, going north, up to 30 degrees, and the magnitude of this vector is 20 newtons. So the line segment that represents this vector is 20 newtons. So now let's see how can we find the components of a vector. In the previous lesson, what we did is we had to find the components of a vector that lies between west and south. And now on this class, we will find the components for a vector that lies into northeast, northwest, and southeast, so that we cover all four quadrants, and as well as when it is due to one of the axes. So let's suppose that we have the first example that is 12 meters per second at 48 degrees north of east. So it is a vector that lies in between north and east, and so north and east, and it is with a magnitude of 12. So the line of the lines of the length of the line segment is 12, is representing 12 meters per second, and the angle with the east is 48. Now, what we said the other day is that from the tip of the vector, we create the right angle triangle that includes a given angle. We have two options to create a right angle triangle: to go perpendicular to the north or perpendicular to the east. Since the given angle is with the east axis, then we will create the right angle triangle that goes perpendicular to the east axis. So this is the right angle. Now, on this way, what we see is that we have two sides of this vector, or this triangle, sorry. One that is along the horizontal and the other one that is along the vertical. And those two are the components of this vector. Now, since the horizontal component is going toward the east axis is a positive value, and since the vertical component is going toward the north axis is a positive value as well. The vertical component is opposite of the given 48 angle, and the horizontal component is adjacent. So now, in order to find the horizontal component, what we will do is we will use cosine, and in order to find the vertical component, what we will do is we will use sine. And the work goes like this: sine of 48 degrees is equal to the opposite, so AV, or vertical component of the vector, over hypotenuse, that is 12. So from here we find that AV is equal to 12 times sine 48, and will be, using your calculator, positive 8.9 meters per second. You can say positive 8.9, or you can say east. And then when we are looking for the horizontal component, we will use cosine. So cosine 48 is equal to the horizontal component over hypotenuse, that is 12. From here, we find that the horizontal component is 12 times cosine 48, and this, using your calculator, this, just make sure that what you are what you are doing is the mode of your calculator is on degrees. And then as the final answer, the horizontal component will be positive 8.0 meters per second. So you can say it is going east, and for the vertical, you can say that it's going north. Next example is, let's suppose that we have something that is between north and west. So we will have a vector B that is 15 kilometers at 27 degrees north of west. As the graphical representation of this vector, what we will have is between north and west. So we'll have a vector that looks like this, be somewhere in between there, that the magnitude is 15 kilometers and the angle with west is 27 degrees. Now, as we said, the steps are from the tip of the vector, we create the right angle triangle that includes the given angle. So the given angle is when you are drawing the perpendicular to the west axis. Here is the right angle. And then as a result of this, you are creating two vectors that are the two sides of this triangle. The horizontal component vector and the vertical component vector. The horizontal component is adjacent of this given angle, and the vertical component is opposite of this given angle. So now we know that when we are looking for the horizontal component, what we have to look for is cosine, and when we are looking for the vertical component, what do we have to use is sine. So now for the horizontal, we'll go cosine 27 degrees is equal to the horizontal component of this vector over the hypotenuse, which is 15. And from here, using your calculator, you will have to find that the horizontal component is 15 times cosine 27 and will be 13.4 kilometers, and since it is going in the west is negative 13.4. And when we look for the vertical component, we will use, as we say here, sine. So sine 27 degrees is equal to the vertical component over the hypotenuse, that is 15. And from here, the vertical component will be 15 times sine 27 degrees. And when you use your calculator, again, I cannot stress it enough that what you have to do is you have to convert, or you have to have the mode of your calculator as degree, 6.8 kilometers. And you have to state the positive, because when you state the positive, you are telling the reader of your paper that you are dealing with a vector quantity. Mathematically, it doesn't make any difference stating the positive or not, but physically it does. So when you are stating the positive sign, you are telling the reader that you are dealing with a vector, and when you are not stating it, then you are leaving the option open to, is this a vector or is this a scalar? The third example is with a vector that lies in between south and east. So let's suppose that we have a vector C that is with a magnitude 25 kilometers per hour at 32 degrees east of south. When we are representing it graphically, we are between east and south, so the vector will be somewhere in between those two axes, and it is with a magnitude of 25 kilometers per hour, and the angle with south is 32 degrees. Now again, from the tip of the vector, we will create a right angle triangle that includes the given angle, which means that the right angle will be formed with the south axis. And then as a result of this, what you will see is two components. There's a vertical component. Why vertical? Because it goes along the vertical, and the horizontal component. Why horizontal? Because it goes with the horizontal on the horizontal direction. So now you see that the vertical component is the adjacent, and the horizontal component is the opposite of angle 32. That means that when we are looking for the horizontal component, we will calculate, or we will use sine, and when we are looking for the vertical component, we will use cosine. So sine 32 is equal to the horizontal component over hypotenuse, that is 25. From here, the horizontal component will be 25 times sine 32 degrees. And when you are using your calculator, 25 times sine 32 degrees will give you 13.2 kilometers per hour. And now it's a horizontal going along the east axis, so it's positive. And even though that is obvious, we write the positive sign there. And when we are dealing with the vertical component, we will use cosine. So cosine 32 degrees is equal to the vertical component over hypotenuse, that is 25. From here, the vertical component will be 25 times cosine 32, and using your calculator, making sure that the mode is degrees, we'll have 21.2 kilometers per hour. But the vertical component is going down, so it's a negative value. Therefore, when we are stating the vertical component of this particular vector, will be negative 21.2 kilometers per hour. Let's see now some examples in which we are dealing with those specific cases, like due east, due north. So when we have a vector D that is 15 kilometers due north, a graphical representation of this vector will be this one here, where the line segment is representing 15 kilometers. Now, the horizontal component of this vector will be equal to 0. There is nothing that no mark left on the horizontal axis. and the vertical component will be positive 15. And when we are dealing with a vector that looks like is 18 kilometers per hour due east, then the graphical representation of this vector will be something like this, where the line of the length of the line segment is representing 18 kilometers per hour. The horizontal component of this vector, E horizontal, will be positive 18 kilometers per hour, and the vertical component will be equals to 0. Now you get the idea that we have. So if we have a vector F that is 22 kilometers due south, then the graphical representation will be something like this. And the vertical component of this vector will be negative 22 kilometers, while the horizontal component is equal to 0. And lastly, if we have a vector G that is 13 kilometers per hour due west, which is represented with a vector like this, then and the line segment represents 13 kilometers per hour. The horizontal component is a negative 13, and the vertical component is equal to 0. This concludes the more examples for finding components that we have done in class. So this is an addition to what we previously had in class. I hope that you understand it. If you have any question, please email me or chat with me.